on Kiwi.
The Radio Wemo Breakfast.
Staring into the night sky, Dylan Storey, representing the Auckland Stardome Observatory here on the show this morning. Hello, Dylan.
Hello, Wemo.
And first up this morning, we're talking about Voyager, one of those probes that NASA sent up a long time ago. How long ago?
1977, so, quite a while ago now. You might I remember it from when I was a kid, people talking about it. They're the ones with the gold plates attached to the side with all the encryptions of and records and things.
Oh, telling possible aliens about humanity.
Yeah, exactly. Yeah, some sort of record of the human existence, I guess.
Yeah.
So they were launched in 1977, and they've been going out. They flew past a lot of the planets and used those planets' orbital speed to help fling the probes out further into space. And now they've left the orbit of the planets long behind. They're well further out than that. They're about 12 light hours away, so the signals, they're still operating fine on less power than an AA battery.
Wow.
And they're still broadcasting signals, and they're still able to be controlled, to be turned around and for the various instruments to work.
That is amazing. That's amazing, and that's 1970s technology.
Yeah. And they're powered by the decay of plutonium atoms. So there's a little bit of plutonium, which of course makes nuclear bombs.
Yeah.
And so it's just the radioactive decay of that that's supplying the heat to power them.
Okay.
Which I find amazing.
Yeah.
So they're a long way away. You send a signal for it to do something. It takes 12 or 13 hours to get there, and then 12 or 13 hours to get back.
Yeah.
So they're taking measurements of what space is like, and the solar wind in particular. The solar wind is the stream of particles that comes out from the sun, and it's completely the dominant force in space certainly around Earth and even all the outer planets. But no one really knows where the solar wind ends and what and where is the edge of the solar system, because the sun is moving through space as it goes, and because it's emitting this solar wind, it's kind of emitting this bubble as it goes. If you can imagine like a boat going through the water, and then you've got the bow shock in front of it as it moves. Well, the sun's got the same thing. It's got a bow shock, and
is the solar wind different to light?
Yeah, it is. Solar wind is particles, and it gets pretty technical, the difference, because light kind of behaves like a particle too. The solar wind travels slower than light, and so technically, the solar wind is physical particles.
Yeah.
Whereas light is something different that behaves like a particle.
Okay.
So when the solar wind interacts with the general background particles of space, that's when you get this kind of bow shock, like a boat going through the water.
Right.
So we've never really known where this is, and there's also a lot of debate raging over what is the edge of the solar system. Is it the edge of the sun's gravitational influence, which would be the Oort cloud, which is much further out, or is it the edge of the sun's sort of radiation dominance in space, like this what we call the heliosphere? And the area, there's a number of terms around this. The area where the heliosphere meets interstellar space is called the heliopause, and the layer between being inside the heliopause and interstellar space is called the heliosheath. And the fact that the radiation the solar wind that the Voyager probes are now monitoring has seems to have lost its force, and seems to be sort of slushing around and no longer the definitive sort of stream of particles in space, suggests that it's entered the heliosheath. So it's entered the sort of boundary area between solar system and not solar system. So predictions are at this stage that the Voyager probes will actually leave the solar system by 2016. It would take that long to get across the heliosheath into interstellar space, and that's going to be very interesting. We'll be able to learn a lot.
Well, will we still be able to communicate with it beyond 2016?
Yeah, I think so. It uses I think it's either low gain or high gain, probably low gain radio signals. So they'll just cut through anything. I mean, even though the you say the solar wind is the prevalent force in space, it's still very thin compared to something like a radio signal or something artificial.
And is Voyager equipped with a camera at all?
Yep, it's equipped with a camera. It's got there's a picture of Earth out there somewhere that it took when it was just leaving, when it was just a little bit, maybe a few years past the orbit of Neptune. It turned around and pointed its camera back at Earth, and took a picture of what the solar system would look like from way out there in space.
Yeah. It was the furthest away picture of Earth. We were just a little dot in that photo.
Yeah.
Yeah. Fascinating. Well, last week we were saying that Endeavour was about to launch. I think it was going to be launching Friday night New Zealand time, but that didn't happen, Dylan.
Yeah, we were getting all excited, weren't we? And as is wont to happen with these shuttle launches, something went wrong at the last minute and they had to cancel. So an electrics box failed, and that means that they had to sort of pull all that section apart and have a look at it, replace the electrics box. And that's been replaced now, and testing is in process. They need an extensive testing process to get these things cleared for launch, and the launch is hoped to be for a Tuesday next week at the earliest.
Yeah.
Quite likely later.
Okay.
So Endeavour is still officially go for launch, just a little bit of a delay. And Space Shuttle Atlantis is still, I believe, due to launch June 28th, but that might be pushed back a bit now by Endeavour's delay.
Okay, well, let's hope that they do at least launch for the final mission. Dylan, what's exciting to be seen at the Auckland Stardom Observatory at the moment?
So the Darwin show is back on at 7 o'clock, which I highly recommend. It's called Natural Selection, sort of this big surround animated show about Darwin's adventures and all that sort of stuff, and his discoveries. The Sky Tonight show is on at 8 o'clock as always, which describes the night sky, what you can see from Auckland, and I was in there the other night, actually, and we had telescopes, which happens after the 8 o'clock show.
Yep.
After the 7 o'clock show, too. This time of year, it's dark enough. And there was Saturn, of course. I know I harp on about Saturn every week, but it's at its best time for viewing at the moment, so get out there and have a look at it, because it's amazing to see through the telescope. Yeah,
and didn't I see, I'm sure I saw some news about some kind of Pink Floyd experience at the at the Stardome.
Yeah, that's on the weekends at 9 o'clock.
Yeah. So that's is that in the planetarium?
Yeah, it's in the planetarium.
Okay.
So the Pink Floyd album is played and graphics are displayed. The graphics have been put together by this crowd in Utah.
Yeah.
And I believe Stardome gets a whole different type of audience for those shows.
It's brilliant. It's a really good idea. Hey, Dylan, thanks so much for that. We really appreciate it. And once again, we'll talk next week.
Cool. Talk next week.
Dylan Storey there from the Auckland Stardome Observatory. Right.